Imagine building a piece of, well, really complex commercial software and realizing you have over 500 critical bugs just sitting there, publicly listed on your development board.
Yeah, that is an absolute nightmare scenario for any developer.
Right. And then deciding that your absolute best strategy to save the entire project is to just completely stop trying to make a profit.
It sounds like professional suicide, honestly.
Yeah.
I mean, if you pitched that to a board of directors at any major tech firm, you would be laughed right out of the room.
Exactly. You pull the plug on corporate scaling, you slash your prices, you give away the bulk of your revenue to your community, and you lock yourself in a room for a year to manually rewire the entire foundational code.
Knowing full well it might break everything your users have already built, it defies every single conventional rule of software capitalization, user acquisition, you name it.
But today, we're looking at a project that did exactly that. We are doing a deep dive into GameGuru MAX.
Which is a fascinating subject.
It really is. So for you listening, if you have ever looked at a video game and thought, I really want to build one of these, you are the exact target audience for this tool.
Because historically, the moment you actually try to cross that bridge from playing games to creating them, you hit this massive, intimidating wall.
Oh, a massive wall. It is constructed out of C++ textbooks, complex rendering pipelines, and frankly, million-dollar budget requirements.
Right. Game development traditionally requires either intense programming knowledge or just massive financial resources.
But GameGuru MAX is a 3D game creation engine built entirely on a no-coding required philosophy.
Which is an incredibly alluring philosophy. I mean, the democratization of game development is a noble goal.
Definitely.
But as we unpack the actual development logs, the architectural shifts, and the, very vocal community feedback surrounding this engine, we're going to see just how extraordinarily difficult that philosophy is to actually execute in the real world of software engineering.
So our mission today is to really get into the weeds of this specific engine to understand the broader realities of game development. We are going to unpack the actual practical capabilities of GameGuru MAX. We will look at the monumental, frankly exhausting, trench-level work required to stabilize an engine of this scale.
The bug fixing.
Yes, the relentless bug fixing. We are also going to examine a terrifying upcoming graphics engine overhaul, and perhaps most surprisingly, we will examine the fascinating, highly unconventional business pivot that is currently keeping this entire project alive.
It's quite the journey.
It is. Okay, let's unpack this. Before we can appreciate the architectural surgery going into the engine right now, we have to establish what this engine is actually designed to do.
Right.
And we need to address the massive tension between what it is and what the public expects it to be.
What's fascinating here is the tension itself. That is really the defining narrative of this software. If you look at the official marketing materials, the promise is basically distilled into 3 words. Dream it, build it, play it.
It's a great tagline.
It is. It positions itself as the ultimate accessible gateway into game development. And to achieve this, it provides a highly visual interface. You have a visual editor where you are literally dragging and dropping 3D objects, buildings, enemies, weapons, just directly into a scene.
No code in sight.
Exactly. You have a storyboard editor designed specifically for linking together title screens, loading menus, and cinematic sequences without having to program state machines.
Which is usually a massive headache for beginners.
Huge headache. And out of the box, it provides over 1,200 pre-built assets.
Now, for anyone who spent time with its predecessor, GameGuru Classic, Max is positioned as this monumental leap forward. Because in the classic version, if you wanted your game to do anything remotely interesting, like having a customized quest trigger or a specific enemy patrol route, you relied heavily on knowing how to script in a language called Lua.
Yeah, Lua. Now, Lua is considered a lightweight scripting language, but, it is still code.
Right. You were still typing syntax, managing variables.
Debugging syntax errors. It's programming. Max attempts to sidestep this entirely with better organization, automatic procedural terrain generation, and fundamentally, this new visual behavior system.
The procedural terrain generation alone is a massive workflow shift.
Oh, absolutely. Instead of developers spending hours hand sculpting every single hill, valley, and riverbed using a terrain brush, the engine just mathematically generates realistic landscapes based on parameters you set.
Wow.
But you hit the nail on the head regarding the behavior system. That is really the engine's attempt to fulfill that no-code promise.
How does that work in practice compared to traditional scripting?
Well, in a traditional workflow, let's say to make a door open when a player gets close, You have to write a script querying the spatial coordinates of the player,
Right.
then comparing them to the door and triggering an animation state if the distance threshold is met. It's a lot of math. In Max, you literally just visually link a player proximity node to a door animation node.
It sounds perfect for a beginner. Honestly, it sounds like exactly what you would want. But when you dive into the community reception, especially the Reddit threads on forums like Archimedev or the deeply passionate Steam community discussions, the reality on the ground is a very different story.
Highly polarized.
Incredibly polarized.
It's a study in conflicting user personas, really. You have a distinct cohort of users who praise the engine for exactly what it is designed to do, which is rapid prototyping.
Like gray boxing.
Yeah, exactly. If you are a designer who wants to gray box a first-person shooter level, meaning you just want to drop basic geometric shapes into a space to test the pacing, the sightlines, and the spatial flow before committing to high-end art assets, GameGuru MAX is incredibly fast.
The drag-and-drop behaviors allow you to get a playable prototype running in minutes rather than days.
Precisely. But then you read the negative reviews.
And there are a lot of them.
There are. Users are incredibly vocal about the lack of official documentation, for one.
Yeah, I saw that. And there were complaints about a total lack of gamepad support.
Which feels bizarre for a modern game engine, honestly.
Totally. And there are severe complaints about poor optimization in certain areas. You have users pointing out that right out of the box, default weapons like the Uzi didn't even fire straight compared to the classic version of the engine.
Yeah, the physics were just slightly off.
But the most glaring, repeated complaint I saw across all the sources was that it is missing basic functionality for non-FPS games.
Right, and this is where that psychological friction between user ambition and the tool's actual software architecture really shows up. You look at these forums, and people are buying this software wanting to build the next massive open-world fantasy RPG like The Witcher 3, or a sprawling, complex survival craft game.
Which is insane for a $40 tool.
Exactly, because GameGuru MAX at a foundational level is rooted in first-person shooter mechanics. The developer himself, along with the core community, openly admits this. You have groups like Blood Moon Interactive who have published notes stating that while you can technically bend the engine's logic to make a puzzle game, an RPG, a horror experience, or an adventure game,
you are fighting against its fundamental nature.
yes, the underlying skeleton you are fighting against is an FPS engine.
Honestly, looking at some of these Steam reviews, the community sounds incredibly entitled. I mean, they are paying $40 for an indie-developed sandbox tool, and they are throwing a tantrum that it doesn't possess the modular architecture of Unreal Engine 5.
It's an expectations issue.
Exactly. Complaining that you can't easily build a complex real-time strategy game in GameGuru MAX is like complaining that a high-end, prefabricated modular home doesn't let you pour your own custom concrete foundation.
That's a good analogy.
It is a modular home. It is not trying to be raw timber and cement. So I have to ask, is the criticism fair? Or is it a symptom of users bringing the wrong expectations to the tool?
Well, while I understand that perspective, I will push back slightly on blaming the users entirely. The marketing has to take some responsibility here.
Fair point.
If you box a product and call it a 3D game maker, you are implying a level of genre universality that the engine simply does not possess. If you buy a generic game maker, you might reasonably expect to be able to make a top-down racing game or a flight simulator.
Right.
But to achieve that in Max without heavy Lewis scripting, which completely defeats the entire no-code marketing hook, is incredibly frustrating, if not impossible. However, you are correct that demanding AAA, sprawling open-world features from a $40 indie tool represents a fundamental misunderstanding of the software's purpose.
It is engineered for hobbyists, students, and indie creators who prioritize seeing their ideas on screen immediately over having infinite technical control.
Exactly. And we should really extrapolate on the commercial viability of this tool because that heavily contextualizes the user base.
Let's talk about the technical export limitations because this stood out to me. GameGuru MAX only exports executable files to 64-bit Windows.
Just Windows PC.
Right. There is no native support for Mac. There is no Linux export. And crucially, there is no push-button export to consoles like PlayStation, Xbox, or the Nintendo Switch.
Which serves as a massive definitive bottleneck if your ultimate goal is widespread commercial success.
Because that's where the money is for indies.
Absolutely. The economics of the modern indie game market rely heavily on multi-platform releases. A massive portion of indie revenue comes from the Nintendo Switch ecosystem, for example.
But compiling for those platforms is hard, right?
It's incredibly difficult. Compiling a game for a Windows PC, which uses x86 architecture, is a completely different engineering challenge than compiling for a Switch, which runs on an ARM architecture.
Oh, I see.
So by lacking the complex cross-compilation tools required for consoles, the engine inherently reinforces its status as a hobbyist tool or an educational stepping stone. It removes itself from direct commercial competition with engines like Unity or Godot, which are built from the ground up to deploy to almost any hardware environment.
Okay, so establishing all of that, you have a tool that is brilliant for quickly throwing together an FPS level, but it was suffering from a reputation of being a buggy, limited asset flipper restricted entirely to the PC market.
A reputation it needed to shake.
Desperately. Because having incredibly smart drag-and-drop nodes doesn't matter if the game crashes every single time a player looks at water.
No, it doesn't.
And that was the exact wall the engine was hitting. Which brings us to the massive, monumental effort by the developer to stop adding fun new features and fix the crumbling foundation. This is what the developers referred to as the trench work.
Trench work is the perfect descriptor for the development cycle leading up to December 2025. Because during its early access period, GameGuru MAX hit a terrifying milestone.
What was it?
They had a peak of over 500 known public-facing bugs logged on their GitHub issues board.
500 known bugs in a piece of software you are actively charging money for. That is a staggering technical debt.
It is the kind of technical debt that frequently sinks entire software projects. Because when you have 500 compounding errors, bugs start interacting with other bugs.
It's like a domino effect.
Exactly. Fixing one thing breaks 3 others because the logic is so tangled. But the lead developer, a man named Lee, made a hard, decisive pivot. The team entered what they internally categorized as Phase 2 of development.
And this phase was just pure bug fixing.
Relentless, unglamorous bug fixing. They halted almost all feature development. No new rendering toys, no new UI overhauls, just pure stabilization. And miraculously, in December 2025, they hit a milestone that is almost unheard of in engine development.
They hit a 0 bug count on their GitHub board.
0 bugs, down from 500.
Taking a complex 3D engine from 500 public bugs to 0 is a Herculean task. And when you read the release notes from that December update, you really start to understand the sheer variety and absurdity of the edge case nightmares they were dealing with. We're talking about fundamental physics failures.
Right, like the underwater spawn bug.
Yes. For example, if your player character happened to spawn underwater when the level loaded, the entire physics initialization process would just break.
Which is a classic race condition in game programming.
A race condition? Meaning what?
Meaning the game is trying to calculate the player's mass and gravity, but the environment hasn't fully registered the density of the water volume yet, resulting in a mathematical failure that breaks the physics state. The calculations are racing against each other.
That makes sense. And it got weirder. There were glitches where the player's swimming arms would physically visibly detach from the camera or warp across the screen.
Hilarious to look at, terrible to play.
Right. There was a pervasive issue where players' start positions were somehow being affected by gravity before the level geometry had even fully loaded.
Oh, that's a classic one.
So you would press play, the game would spawn you in, but because the floor hadn't materialized in the engine's memory yet, gravity would instantly pull you down and you would just fall endlessly through the void.
And those were just the issues within the editor itself. The standalone exports, the actual bundled executable files that a developer would distribute to their players or put on Steam, were an entirely different battleground.
Oh man, exporting games is always where things fall apart.
Always. Developers would spend months building a game, hit export, and suddenly vital UI elements like quest images were missing from the compiled build.
Or custom explosion particle effects simply wouldn't trigger.
Right. Embedded video playback for cutscenes would fail to initialize, and fundamental things like in-game music volume sliders simply wouldn't respond to player input.
It sounds like a complete house of cards. But to address this, they didn't just play whack-a-mole with the bugs. They actually had to build better diagnostic tools to even find the bugs in the first place. They introduced a new crash log system.
Yes, specifically the implementation of the GG crash context macro.
Okay, we need to pause here. What exactly is a macro in this context? Because that's a term thrown around a lot in tech that isn't always super clear to the layperson.
Sure. In C++ programming, a macro is essentially a rule or pattern that specifies how a certain input sequence should be mapped to a replacement output sequence. But in the context of a crash logger, the GG crash context macro is a piece of code wrapped around other functions.
Like a wrapper.
Exactly. When a function runs, This macro records the current state of the machine, the variables, the memory addresses.
Because before this, how did they know why a game crashed?
They didn't. Diagnosing random crashes in Max was largely guesswork. You'd rely on users vaguely describing what they were doing when the game froze. I was shooting a gun and it stopped.
That's not helpful for a programmer.
Not at all. To understand why this macro matters, you have to understand how engine development works. When a game crashes to the desktop, the program just abruptly ends. The developer needs to know exactly what the computer was thinking in the millisecond before it died. They need what is called a stack trace.
A stat trace.
It's a literal, chronological map of the specific functions the code was executing leading up to the failure. This new macro system automatically generates highly detailed stack traces and parameter values.
But doesn't constantly logging everything slow the game down?
It does. Constantly logging memory states takes up processing power. So smartly, they gave users the ability to disable this logging once their specific game is stable, reclaiming that CPU power for game performance.
The technical execution of that is impressive, but I want to talk about the culture shift required to do this. From a psychological and business standpoint, how difficult is it for a developer to look at their community, ignore the loud voices begging for shiny new features, take the public relations hit of the software appearing stagnant, and spend an entire year just untangling messy code?
It requires extreme discipline and a real willingness to absorb intense criticism. Because releasing with hundreds of bugs destroys trust. A game engine is a foundational tool. If you are building a house and the concrete foundation is cracking, you aren't going to spend years framing walls and putting on a roof. Developers simply won't invest years of their life building a game on an engine they don't trust. So Lee had to dive deep into the legacy code. He spent months systematically stripping out old #ifdef blocks.
Break down the #ifdef blocks for us. Why were they causing so much trouble?
Well, #ifdef stands for if defined. It's a preprocessor directive in C++N. Essentially allows a programmer to conditionally compile certain blocks of code.
Like a switch.
Sort of. If a specific condition is true, include this code. If not, ignore it. Now, GameGuru MAX shares DNA with GameGuru Classic. Over the years, the code became littered with these #ifdef statements, essentially saying, if we were running the classic engine, do this old thing. If we're running YAX, do this new thing.
Oh, I see how that gets messy.
Very messy. Leaving these in creates massive bloat. It makes the code incredibly difficult to read, update, and optimize because the compiler has to constantly check these conditions, and developers can easily get confused about which block of code is actually executing. Removing them was a painful, tedious process of permanently severing the engine from its old classic architecture.
And the irony is that the untangling process itself creates entirely new, unpredictable problems. I absolutely love this specific anecdote from the development streams. They were doing all this deep under-the-hood optimization, restructuring how the CPU processed logic to make the engine run faster.
Right.
But because they successfully made the logic cycle faster, it completely broke the animation timing. It accidentally turned the NPC walk animations into this comical, high-speed scurrying. The community dubbed it the Charlie Chaplin bug.
It is a perfect textbook example of how deeply interconnected game systems are. In older game engine architectures, animation playback speed was sometimes tied to the CPU cycle speed rather than real-world time.
Which is wild to think about.
It is. You optimize the CPU cycles to process logic faster, and suddenly your terrifying, menacing zombies look like they are in a sped-up, silent comedy film.
And what was the fix for that?
Well, the temporary triage fix for this was literally applying an arbitrary 70% speed reduction to all character animations universally, just to get them looking somewhat normal again while they fix the underlying timing logic.
It is hilarious, but it really highlights the fragility of game code. You pull one thread to fix a memory leak, and suddenly the zombies are doing slapstick routines.
Exactly.
So what does this all mean from a development standpoint? How dangerous is it to release a product with 500 known bugs?
Well, it's a huge gamble. But by pushing through that trench work, they actually got the issues board down to 0. The game stopped crashing every 5 minutes.
But having a stable game is only half the battle.
That's right.
A stable game that is boring to play is still a failure. And the biggest complaint about the gameplay was that the enemies were essentially brain dead. This leads us directly into the AI and behavior revolution.
Precisely. If we look back at the Steam reception during the buggy period, there were 48 highly specific, explicitly negative reviews that bypassed the crashes and called out one specific gameplay flaw. Dumb AI.
Dumb AI.
Users felt that the engine allowed them to drop an intimidating-looking enemy into a level, But that enemy possessed absolutely zero tactical awareness. They would just run in a straight line directly at the player or stand completely stationary in an open field while getting shot.
Which completely shatters any sense of immersion or attention. I mean, you can't build a compelling shooter if the targets behave like carnival ducks.
You really can't.
So between the September and December 2025 updates, the developers completely gutted the artificial intelligence system and rebuilt it from the ground up. And the foundational change started with how the engine handles the nav mesh.
The navigation mesh, or nav mesh, is critical to understand here. Think of it as an invisible map projected over the game world that tells the AI precisely where it can and cannot walk. It understands the geometry of floors, the blockage of walls, and the height of stairs. It is what pathfinding algorithms, like the industry standard A-star algorithm, use to calculate a route from point A to point B.
So how was GameGuru MAX handling this before the overhaul, and why was it failing so badly?
Previously, to save processing power, the engine generated this nav mesh dynamically based purely on where the editor camera or the player camera was currently looking.
Wait, so it only built the map right around the player?
Yes, it only built the invisible map locally. That is a terrible system for large open-world levels because if an enemy is spawned far away outside the immediate camera view, they literally have no map. They don't know how to navigate their surroundings until the player looks at them.
Wow, so they were essentially frozen until you stared at them.
Basically, the update completely overhauled this system, so the engine now pre-generates a high-quality nav mesh globally for the entire level at runtime.
So now an enemy 3 buildings away actually knows the layout of the environment and can plot a path to the player. But they went far beyond basic navigation. They introduced highly complex cover systems. They cite taking direct inspiration from AAA games like Fallout and Half-Life. Enemies no longer just stand in the open. They actively seek out geometric cover. They will peek out from behind a concrete barrier, fire off a few rounds, and retreat back into cover.
And what really impressed me is the dynamic evaluation. If the player rushes the enemy and gets too close, the AI evaluates the distance, breaks its current cover, and tactically retreats to a safer cover zone further back in the environment.
That sounds incredibly processor heavy.
It requires a massive amount of real-time spatial calculation. The AI is constantly casting invisible lines or raycasts to check the line of sight between itself and the player while simultaneously querying the nav mesh for nearby objects tagged as cover.
That is a huge step up.
And they also introduced threat states. The AI knows the difference between idle, suspicious, and engaged. They added flashlight logic. If the environmental lighting drops below a certain threshold, the AI automatically turns on a flashlight and searches for the player.
Oh, that adds so much atmosphere.
It does. If they are engaged in combat, they evaluate the distance and seamlessly switch between firing a ranged weapon and switching to a melee attack if the player gets within striking distance.
And looking ahead to future updates, they are currently prototyping something called Commander Mode, which completely changes the paradigm of AI behavior.
Commander Mode is a fascinating addition. In most basic shooters, every enemy acts as an individual, isolated unit. They only care about their own line of sight. Commander Mode introduces a master AI logic. Think of it as an invisible director, or it can be physically assigned to a specific commander NPC unit.
So like a squad leader.
Exactly. This master logic coordinates the grunt units. It analyzes the player's position on the nav mesh and can order multiple enemies to execute a flanking maneuver from different angles simultaneously.
That's terrifying for the player.
Right. Or, if the player is overwhelmingly powerful, it can order a coordinated squad retreat. It turns a disorganized mob of independent agents into a tactical squad operating on a shared state machine.
That drastically changes the core feel of the game from an arcade shooter to a tactical experience. But they didn't just update the gunplay, they completely overhauled the melee combat system too. And they took notes directly from one of the most mechanically demanding games in modern history, Dark Souls.
Yes, the implementation of invincibility frames, commonly referred to as iframes.
How did melee work before?
In earlier versions of GameGuru MAX, melee combat was rudimentary. It was basically just clicking the left mouse button, playing a swinging animation, and watching two invisible health bars deplete based on proximity. There was no skill involved at all.
Just clicking until someone falls over.
Exactly. The overhaul fundamentally changes this by assigning a blocking mechanic to the right mouse button.
But it's not just holding a block button to negate damage, right? It relies on extremely precise timing.
Right.
If a player times their block perfectly so that it intersects with the exact animation frames of the enemy's attack, it triggers an iframe. For a split second, the player cannot take damage, and more importantly, it triggers a counterattack window. The engine physically registers the parry, the enemy plays a stumble animation backward, and they are left open for a critical hit.
The underlying engineering for that is quite complex. It requires robust collision detection synced perfectly to animation timelines. You are no longer just calculating distance, you are calculating the exact millisecond. A weapon mesh intersects a defensive hitbox and then interrupting the enemy's current behavior state to force them into a stumble state.
But what makes this accessible to the user is that all of this complex AI logic, the cover systems, the flanking, the iframes, is funneled through the visual behavior system.
The behavior system is heavily expanded in these updates. And this is where the no-code promise really gets its trial by fire. A beginner can literally drag a behavior node labeled Sniper onto a generic 3D character model, and that character instantly adopts the logic of a sniper.
Seeking high ground, taking delayed shots, maintaining distance.
Exactly, without the user typing a single line of script. But what the recent updates did was add incredible granularity to how these nodes can be customized. A perfect example is the delayed shot logic introduced in the gunspec file parameters. Developers now have millisecond precision over the mechanical delay between when an AI pulls the trigger and when the weapon actually fires.
Why does a millisecond delay matter so much in game feel? I mean, it's just a tiny fraction of time.
Because millisecond delays are how you simulate weight and mechanics in a digital space. If an AI is firing a lightweight pistol, it should fire instantly. But if they are firing a massive shoulder-mounted rocket launcher, an instantaneous shot feels weightless and cheap.
Like a toy.
Right. There should be a split-second mechanical delay, the sound of the hammer locking, the hiss of the ignition before the explosion. This tiny delay gives the player a fraction of a second to react, which feels fair and tactile.
That makes total sense.
They also introduced animation choice modes to the visual nodes. A developer can dictate whether an enemy cycles through their physical attack animations sequentially, always punch, then kick, then slash, or if the AI picks them randomly. Randomizing the attack animations makes the combat feel much less robotic and predictable.
They also added entirely new visual logic nodes, like the mesh sensor and entity in zone. So completely without coding, you can visually map out a sequence that says, if the player's 3D mesh physically enters this invisible bounding box, trigger this specific explosion effect, and command this specific group of enemies to run to that specific cover.
It empowers level designers to create scripted cinematic moments visually. But crucially, the developers realized that a visual node system will eventually hit a ceiling.
Yeah, visual scripting can only go so far.
Exactly. A visual flowchart simply cannot replicate the infinite flexibility of raw code, so they did not abandon the power users. For developers who find the visual nodes too limiting, the engine still fully supports custom Lua scripting.
They actually leaned into it for the advanced users, right?
Yeah, they did. Alongside the visual updates, they provided new, highly complex Lua scripts like dispenser.lua and deployable.lua for advanced users to study and modify.
And the dedicated community heavily relies on external text editors like Notepad++S using custom syntax highlighting add-ons to write deep, bespoke logic that the visual drag-and-drop system couldn't possibly handle efficiently.
Absolutely.
But this brings up a fascinating philosophical dilemma in game design. Programming AI is essentially like directing incredibly obedient actors who possess absolutely zero common sense. If you hand them a script, they will execute it flawlessly, but if you forget to explicitly write the logic telling them not to walk directly into a roaring campfire, they will happily march into the flames and burn to death.
A very common problem in development.
Right. So I have to ask you, if the developers make this built-in AI too smart with perfect cover usage and flawless flanking, do they risk alienating the beginner game developers who don't understand how to balance game difficulty?
It is a very real, very dangerous risk. If you provide a beginner with an AI that acts like a highly trained SWAT team, hyperlethal, perfectly accurate, and flawlessly executing flanking maneuvers, the game quickly stops being fun and becomes brutally frustrating.
Because the beginner developer might just drop 5 of these enemies into a room, not realizing they've just created an impossible death trap for the player.
Precisely. They just think, more enemies equals better. The solution to this, which GameGuru MAX seems to be adopting within its behavior system, is exposing highly customizable parameters.
Okay, how does that work?
Well, you engineer the incredibly smart AI under the hood, but you expose simple visual sliders to the user for things like reaction time delay, accuracy spread, and field of vision radius.
Yeah.
You give the beginner the tools to easily dial down the smartness, introducing intentional flaws into the AI so the player still has a chance to feel like the hero.
Dialing down the smartness to make the player feel heroic. I love that concept. Okay, so we have traversed the trench work. The engine is stable, the bugs are fixed. We have explored the behavior revolution, the enemies are tactical, and the game plays well. But we exist in a modern gaming landscape where players demand incredible visual fidelity and buttery smooth frame rates.
They expect AAA graphics.
They do. A game can play beautifully, but if it looks dated and stutters every time you turn the camera, the modern audience will abandon it immediately. And that reality transitions us into what is easily the riskiest, most terrifying part of this deep dive, the engine room surgery.
This is where the technical narrative of GameGuru MAX shifts from tedious bug fixing to dramatic, high-stakes architectural replacement. To understand the risk, we have to understand what is currently powering the graphics.
Okay, break it down for us.
Currently, the engine runs on a graphics API called DirectX 11, specifically utilizing an underlying graphics rendering engine called the Wicked engine. But Max is using a branch of the Wicked engine that is roughly 2 years out of date.
Now, for our listeners who might not be deep into hardware programming, what exactly is a graphics API and why does a 2-year-old version matter so much?
Well, API stands for Application Programming Interface. In the context of graphics, think of the API as the ultimate translator between the game's software code and the physical hardware of your computer's graphics processing unit, the GPU.
So the game can't just talk to the hardware directly.
No, the game code doesn't know how to physically turn on the millions of microscopic transistors in your graphics card to draw a shadow. It asks the API to do it. DirectX 11 is an older translator. It was designed for an era where games operated differently.
And 2 years is a long time in tech.
2 years in the tech world is a lifetime because hardware evolves so rapidly. And because Max is using this older DirectX 11 translator, it suffers from a massive fatal bottleneck regarding video RAM, or VRAM.
VRAM is the memory dedicated purely to handling graphics, right?
Correct. When game developers build large, detailed outdoor levels using high-resolution textures, say incredibly detailed brick walls or photorealistic tree bark, the engine has to load those image files into the VRAM so the GPU can paint them onto the screen.
Okay.
Under the old DirectX 11 architecture, if a massive texture was anywhere in the level, the engine would often try to load the entire massive file into the VRAM.
Even if you weren't looking at it.
Even if it was far away. As the player runs through the level and turns the camera rapidly, the engine is frantically trying to swap gigabytes of massive textures in and out of the limited video memory.
It's like trying to pour a gallon of water into a shot glass, pouring it out and pouring another gallon in over and over again.
That's exactly it. This frantic swapping is called memory thrashing. The bandwidth gets clogged, the GPU have to pause and wait for the files to load from the hard drive, and the result is aggressive, highly noticeable stuttering and frame rate drops during gameplay.
And absolutely nobody tolerates stuttering in a fast-paced first-person shooter. You turn a corner to shoot an enemy, the game freezes for half a second to load a wall texture, and you are dead.
It ruins the experience entirely.
So what is the developer's solution to this fundamental hardware bottleneck? Lee, the lead developer, makes a shocking announcement. He is stepping back from the day-to-day updates of the DX11 version, handing much of that maintenance over to a highly trusted community contributor named Prebin.
Right.
And Lee is isolating himself to prototype a parachute drop replacement of the entire rendering pipeline using the absolute newest DirectX 12 version of the Wicked engine.
The jump from DirectX 11 to DirectX 12 is monumental because DX12 allows the software to speak directly to the GPU hardware with much less overhead. But this specific game-changing feature they are chasing to solve the stuttering is called texture streaming.
Explain texture streaming. How does it fix the VRAM thrashing?
Well, instead of the old method of brute forcing an entire massive texture file into memory just because it exists somewhere in the level, texture streaming relies on multi-threading and dynamic resolution scaling.
Okay, walk me through that.
The engine utilizes the computer CPU to asynchronously read data from the file system. It mathematically calculates exactly how far the player's camera is from an object and the angle of the view. Based on that math, it dynamically loads only the exact texture resolution required for that specific frame.
So let's say if you are building a level and you apply a massive 8,000 by 8,000 pixel high definition texture to a brick wall.
Right.
but the player is currently standing half a mile away in the game world. The engine doesn't load the 8K texture. It loads a tiny, heavily compressed, blurry version of it, what developers call a mipmap.
Exactly.
It doesn't waste precious VRAM memory rendering microscopic details that the player's camera can't even perceive yet.
Precisely. As the player runs closer to the wall, the engine smoothly and dynamically streams in the higher resolution layers in the background. The result of this architecture is that you can maintain a silky smooth 60 frames per second, regardless of how many massive photorealistic textures are scattered across a giant open-world environment.
That's incredible.
The only artifact a player might occasionally notice is a slight blur on a distant object for a fraction of a second before it sharply snaps into high resolution as the stream catches up.
So the performance gains are massive, but it is also a huge visual uplift. The DX12 Wicked engine brings advanced global illumination.
Yes, the lighting changes completely.
Instead of older baked lighting where shadows are pre-drawn onto textures, global illumination calculates light bounce in real time. If you place a bring red neon light in a room, the light doesn't just illuminate the wall next to it.
Right, it bounces.
The light mathematically bounces off the red wall, picks up that specific red color value, and realistically casts a soft secondary red glow onto the concrete floor. It mimics how photons operate in reality. They also mention velocity-based motion blur, which tracks the speed of individual objects to blur them accurately, making animations look incredibly cinematic.
And all of this visual fidelity is achieved without sacrificing the frame rate, because DX12 is fundamentally more efficient at distributing the processing workload across modern multi-core computer processors.
But there is a massive catch.
There's always a catch.
And this is where the terrifying reality of software development comes in. Replacing the underlying graphics API of an existing live game engine with active users is an incredibly perilous undertaking.
If we connect this to the bigger picture, it's the ultimate nightmare scenario for backward compatibility. To understand why it's so risky, we have to look at the concept of an abstraction layer.
Abstraction layer.
Yes. In ideal software architecture, an abstraction layer is designed to completely separate the core game logic, the AI, the player movement, the physics, from the graphics renderer. In theory, this allows a developer to swap out the graphics engine without breaking the game itself.
Right, in theory.
But in practice, especially with 3D games, graphics and gameplay are deeply, intimately intertwined.
And this is exactly what GameGuru MAX is facing. Because over the last few years, while operating on DirectX 11, the GameGuru development team spent countless hours custom writing their own procedural terrain generation algorithms.
They did.
They wrote their own proprietary systems for rendering thousands of trees and highly optimized custom shaders for rendering fields of moving grass. If they successfully move to the DirectX 12 Wicked engine, all of that proprietary code has to be thrown into the garbage.
Every single line of that custom DX11 rendering code becomes completely useless. They're forced to abandon their proprietary systems and fully adopt the Wicked engine's built-in terrain and foliage systems to ensure compatibility with the DX12 pipeline.
Here's where it gets really interesting. This has massive implications for the user base. Imagine you are an indie developer. You have spent the last year meticulously building a massive outdoor adventure game in the DX11 version of Max. You have hand-placed forests, you have sculpted specific hills for tactical encounters.
All that work.
If you upgrade your project to this new DX12 version, the underlying math defining the terrain changes. Your custom hills might suddenly be flattened. The new foliage system might dictate that grass now grows right through the floorboards of the buildings you meticulously placed. The new global illumination will completely change the mood and contrast of your carefully lit horror levels.
It's devastating for current projects.
It has the potential to completely break the visual identity and structural integrity of existing user games. I mean, my analogy for this is extreme. This isn't just a fresh coat of paint. This is ripping the engine out of a car while it's driving down the highway and hoping the new engine fits the old transmission.
That is a very apt metaphor.
So I have to ask, is this upgrade driven by necessity, or the developer's self-admitted obsession with tinkering on the cutting edge?
It has to be a mixture of both, right? But necessity plays a far heavier role than ego here. The harsh, unavoidable reality of software engineering is hardware obsolescence.
Windows operating systems evolve.
Companies like AMD and NVIDIA constantly release new hardware and updated graphics drivers. Eventually, the hardware manufacturers will stop optimizing their drivers for the older DirectX 11 architecture. They will shift all their focus to DX12 and whatever comes next.
So if Max stays on DX11?
If GameGuru MAX stays anchored to DX11 forever to protect backward compatibility, eventually over the next few years, the engine will start suffering from mysterious crashes on new graphics cards. Eventually, it will simply fail to boot on modern PCs. It will become a relic. Enduring the pain of upgrading to DX12 now is an act of future-proofing the software for the next 5 to 7 years.
So some massive risk, yes, but remaining stagnant is a guaranteed death sentence?
Exactly.
So we are looking at a situation where a developer is spending an entire year locked away, prototyping an engine replacement, essentially rewriting the language of the play mid-performance. To understand how a developer can possibly afford the time, the salary, and the resources to do something this risky, with zero guarantee of a financial return, we have to pull the camera way back. We have to look at the massive structural earthquake that occurred within the company itself.
This brings us to the business pivot.
Yes. In June of 2025, there was an announcement that completely shook the core community. Lee, the original creator and lead programmer of all these game-making tools, officially executed a buyout. He purchased all of the game-making intellectual property back from his longtime business partners at the Game Creators, commonly known as TGC.
He bought back the rights to everything, dating all the way back to his original tech startup in 1999.
And he formed a new umbrella company to house this IP, returning to the exact identical name of that 1999 startup, Dark Basic Software Limited, or DBS.
From a narrative standpoint, it is an incredibly poetic move, returning to his absolute roots. But this wasn't driven by nostalgia. It was driven by stark, unforgiving financial realities in the software market. For TGC, trying to operate as a traditional corporate entity, attempting to sell a mid-tier game engine to indie developers for $40 or $50 is a nearly impossible business model in today's landscape.
Because the entire market has been completely distorted by the AAA giants adopting a freemium model. How does a small company sell an engine for $50 when Epic Games lets anyone download Unreal Engine 5, the exact same software used to render effects for The Mandalorian, and build Fortnite completely for free?
You can't compete with free.
With Unreal, you only pay a royalty if your game makes $1 million. Unity has offered massive free tiers for years. How do you convince a teenager or a hobbyist to pay $50 for GameGuru when they can download the most powerful tools on Earth for nothing?
You simply don't. The freemium AAA model completely hollowed out the mid-tier software market. TGC looked at the ledger and realized that the revenues generated from selling proprietary game-making tools were in a steep, irreversible decline. It was no longer viable to support a large corporate infrastructure.
However, TGC had smartly pivoted their business into another market entirely, developing driving tests and educational applications for mobile phones.
They had dominated that space, holding the #1 app spot for 7 years. That mobile app market was highly reliably profitable.
So the split makes perfect sense. TGC takes the highly profitable driving apps and focuses on corporate growth, and Lee takes the struggling game engines and forms DBS. But what Lee does next is what makes this story so unique. He introduces what he calls the infinity model.
The infinity model?
He openly admitted on a live stream broadcast that under DBS, GameGuru MAX currently operates at break-even. Think about that. DBS is no longer a profit-driven corporate entity desperately trying to scale, acquire venture capital, or dominate market share. Lee stated that as long as the software sales cover the monthly server hosting bills, he is content. It is a 24/7 creative endeavor. He sits in his office, coding for the sheer joy of solving puzzles, driven entirely by passion rather than the pressure of hitting quarterly profit targets.
It is a radical, almost anti-capitalist pivot. By explicitly abandoning the immense pressure to scale the business and accepting that he will never compete financially with a behemoth like Epic Games, Lee found absolute creative freedom. He doesn't have a board of directors forcing him to rush the DX12 update out the door to meet a holiday sales quarter.
And this newly found financial freedom allowed DBS to fundamentally change how they handle their ecosystem, specifically regarding downloadable content, or DLC, which culminated in a massive restructure in October 2025.
The October DLC restructure is where the philosophy of community management truly shines. Previously, to make money, the company sold these fixed-price asset packs, booster packs, mini-kits, specialized weapon packs. If you wanted new zombies, you paid $15.
Pretty standard stuff.
But in October, DBS slashed the prices of almost all their asset packs by a massive 50%.
A permanent price cut designed specifically to lower the financial barrier to entry for the hobbyists and students they are trying to attract. But what is truly incredible and virtually unseen in modern software marketplaces is how they handled the revenue split for the assets created by the community.
They raised the royalty rate paid directly to the community creators to 70%.
70%.
The remaining 30% goes entirely to paying Steam's mandatory platform commission. DBS, the parent company, intentionally takes zero profit from these community DLC sales. They only generate revenue on the core, upfront software sales of GameGuru MAX itself.
They literally gave up their entire cut. They architected a system where the community artists make more money while the end buyers pay significantly less, and they went even further than that. DBS took all of their own internally created premium DLCs alongside 16 DLCs graciously donated by top community artists, and they absorbed all of them into a massive new starter kit bundle, priced at just $1 single.
We are talking about thousands of 3D models, textures, and scripts, practically given away to ensure that new users have a massive library to play with the second they open the software. By restructuring the business this way, the community is no longer viewed merely as a consumer base to be monetized. They have been elevated to active co-developers. They are the ones creating the high-quality assets. They are the ones scripting the complex Lua behaviors and sharing them on the forums. They are actively suggesting UI workflow improvements, like successfully lobbying to move the grid snapping settings out of a buried object properties menu and onto the main toolbar.
That's real collaboration.
By removing the corporate profit motive, DBS has essentially crowdsourced the survival of the engine. The community is keeping the software alive and relevant.
It is such a fascinating counterintuitive irony. Usually in the tech world, a product is considered successful because it is a heavily funded, aggressively marketed, highly profitable business. Here, it seems GameGuru MAX was failing when it tried to act like a traditional business, and is only surviving and perhaps finally finding its true footing because it explicitly stopped trying to be one.
It voluntarily stepped off the corporate treadmill.
But looking at this objectively, I have to ask you, can a piece of software of this immense technical magnitude, a 3D rendering engine, truly survive long-term, relying purely on community goodwill, break-even economics, and one single lead developer's passion?
It is the ultimate stress test of the open community model. I believe it can survive, provided the community remains highly engaged and, critically, the core developer does not succumb to burnout. The absolute biggest risk to the infinity model is what software engineers call the bus factor.
The bus factor.
It's the terrifying hypothetical that if Lee gets hit by a bus or simply decides to retire, the entire engine stops evolving instantly because the architectural knowledge is isolated in one mind.
I see.
However, by empowering highly skilled community contributors like Preben handling the DX11 maintenance, they are slowly beginning to decentralize that risk. It is a fragile ecosystem, undoubtedly, but history has shown that systems built on genuine passion can be remarkably resilient compared to systems built purely on venture capital.
It really is a phenomenal case study in modern software survival. Over the course of this deep dive, we have unpacked an engine that has completely surrendered the fight against giants like Unreal and Unity. We've looked at a tool that hit absolute rock bottom with over 500 critical bugs, halted all the fun, marketable features to manually rebuild its foundation, completely gutted and rebuilt its artificial intelligence so enemies actually possess tactical awareness, and is now actively ripping out its own graphics engine to future-proof itself with DirectX 12, regardless of the risk.
It's been a wild ride.
And it achieved all of this while executing a radical business pivot, giving up its profit margins and handing the keys over to its community. For you, the listener, whether you are an aspiring game developer, an architect of software, or just a technology enthusiast observing the industry, GameGuru MAX serves as a raw, unfiltered masterclass in realistic software development, managing user expectations, and the power of anti-corporate community management.
It truly is a unique artifact in the industry. And examining its philosophy raises a highly provocative question, something for you to mull over long after this deep dive ends. This raises an important question. In one of the recent live development broadcasts, Lee speculated about the future of game creation. He suggested that in 5 to 10 years, the traditional role of a programmer might completely vanish.
Vanish entirely.
He thinks we might all simply become prompt engineers, where highly advanced generative AI models do all the heavy structural coding for us based on natural language requests. As we rapidly accelerate toward that generative AI future, will traditional complex game engines, even highly accessible ones trying to simplify the process like GameGuru MAX, become entirely obsolete? Or will this visual, no-code, drag-and-drop philosophy championed so fiercely by Max actually become the absolute foundational standard interface for how human beings interact with AI to create all digital media in the future?
That is an incredible thought. You start out as a kid, holding a controller, wanting to build a world. And eventually, the tools might evolve to simply build the world for you exactly as you describe it. We started this exploration talking about that universal childhood dream of crossing the bridge from player to creator. GameGuru MAX, with all of its documented flaws, its muddy diagnostic waters, its terrifying architectural risks, and its incredible community-focused business pivots, is fighting tooth and nail to keep that specific hands-on dream alive for the hobbyist. Thanks for joining us on this exploration. Keep dreaming, keep building, and we'll see you on the next deep dive.